When you flip the thermostat to cooling, a 24-volt signal energizes the contactor coil and completes the high-voltage circuit that powers the compressor and outdoor fan almost instantly. When the thermostat calls for cooling, it closes its internal relay and sends a steady 24-volt control signal down the control wire to the outdoor unit. That voltage actually energizes the contactor coil, which is a low-voltage electromagnet mounted on the condensing unit. The energized coil pulls in a plunger that mechanically closes the contactor's set of heavy-duty contacts, and those contacts connect the two hot legs of the household 240-volt supply to the compressor motor and the fan motor. Without the coil pulling in, the high-voltage circuit remains open and nothing runs. Inside the compressor, three-phase or single-phase windings receive line current. The start and run circuits engage, including start capacitors and potential relays on single-phase systems, and the motor begins compressing refrigerant vapor, raising its pressure and temperature so the condenser coil can reject heat. At the same time, the outdoor fan receives line voltage and spins to move air across the condenser. Proper fan motor rotation and blade condition are essential for correct airflow and head pressure control. Good practice is to verify 24-volt presence at the contactor coil with a multimeter before touching high voltage lines. Then check that the contactor contacts have continuity when energized and show low resistance when closed. Measure run and start capacitor microfarads and motor amp draw against nameplate values if the compressor struggles to start. If you install or replace a thermostat, program the anticipator or configure the cycle rate correctly. Use a common wire when required to supply power to smart thermostats, and always de-energize power at the outdoor unit disconnect and breaker before pulling control wires or swapping components. For long life, keep the contactor and relay faces clean, replace pitted contacts promptly, and ensure the outdoor unit has correct refrigerant charge and clean condenser coils so the compressor does not short cycle under high head pressure. One of the most common issues is thermostat wiring errors, causing no call for cooling or a shorted control circuit. Fix this by tracing and labeling each control conductor, confirming 24-volt on the R and Y terminals at the thermostat, and replacing frayed wire or bad connectors. One of the next frequent problems is a failed contactor or welded contacts preventing fan or compressor operation. Diagnose by checking coil voltage and then inspect contact faces for welding or pitting and replace the entire contactor assembly rather than trying to clean badly damaged contacts. One of the third typical faults is start component failure, bad start capacitor or relay, leading to a compressor that hums but will not start. Measure capacitor microfarads with a meter. Swap with a known good unit if values are out of tolerance, and confirm motor amp draw is within nameplate limits to avoid running a weak compressor into overload. BigHomeProjects.com lists trusted local contractors who specialize in heating, ventilation, and air conditioning, and makes it easier for homeowners to find qualified professionals for thermostat wiring and condensing unit work. The directory also helps contractors get more work by showcasing verified reviews, licenses, and service photos so homeowners can hire confidently.